Hello, and thank you for joining me for today's lesson as we continue our discussion on gases and energy. Today we're going to talk about specific heat. And so at the conclusion of this lesson, you will be able to convert between calories, kilocalories, and joules, which are all measures of energy. You'll be able to define specific heat. You'll be able to explain what this indicates when comparing two different substances. And you will be able to perform specific heat calculations. So that is today's task, and let's get after it. Well, so for starters, heat is the transfer of energy, and in this case, it is measured in calories. We can measure it in a couple of things, but we're going to measure it in calories. So 1 calorie is the amount of heat needed to raise the temperature of exactly 1 gram of water by 1.0 degrees Celsius. So that's the heat needed. And this is kind of our base unit. We also have what are called kilocalories, or kcals. This is what we think of when we think of a food calorie. So this is it could also be a capital C calorie is the same thing as a kilocalorie. Or we have joules. So we have calories, we have kilocalories, and we have joules. Joules are your SI unit for energy. So a lot of times in science we're going to use joules, but we can use these other two. We will use these other two in here. Conversion-wise, 1 calorie is the same as 4.184 joules. 1 kilocalorie, kilo meaning 1,000, is the same as 1 capital C calorie, which is the same as 1,000 little c calories, regular calories. And then 1 kilojoule is the same as 1,000 joules. Again, kilo being 1,000, 1,000 joules there. All right. If we're talking specific heat, so instead of just regular heat, we're talking specific heat. This is the amount of heat, amount of energy, needed to raise the temperature of 1 gram of substance by 1 degree Celsius. This is for any substance. So the amount of energy or heat needed to raise the temperature of 1 gram of substance by 1 degree Celsius. Units are going to be either calories per gram degree Celsius or joules per gram degree Celsius. And your substances are going to need different amounts of energy to change temperature. And that's kind of what makes different substances unique and useful and not useful in other cases. So let's talk a little bit more about this. Here's a chart. You will notice the specific heats of different substances. And you'll notice at the top, we have this substance that we use a lot. It's called water. Water has an extremely high specific heat, meaning it takes a lot of energy to raise the temperature of water. This is why it takes lakes a long time to warm up. This is why oceans stay at relatively the same temperature. This is why islands have fairly mild climates. This is because they're surrounded by water that has extremely high temperature. Other substances, alcohol, wood, aluminum, sand, iron, copper, silver, and gold. Look at all these small numbers, very small numbers, especially compared to this 1 or this 4.184. Fractions of the number. So very small specific heat. So if you gave the same amount of energy to these two different substances, one is going to heat up a lot, one is not. For example, if you gave water and let's go sand, the same amount of energy, because water has a specific heat of 1 and sand is 0.19, which is almost 0.2, your sand is going to increase by 5 more degrees than your water will. If you give 1 gram of each substance the same amount of energy, sand would be 5 degrees warmer than your water would. So it heats up much quicker. And that's why when you go to the beach and you step on the sand is really hot, the water is really cold. And that all relates there. All right, looking at the specific heat chart, why are copper pans more desirable than aluminum pans? So look at this. Why would copper be a better pan to work with than aluminum in terms of cooking food? Well, in this case, copper has a specific heat of 0.093, aluminum 0.22. This is calories per gram degree Celsius. So it takes less energy to heat up copper, so your copper pan gets hot faster. And so it can cook your food quicker. It also cools down faster. So after it's warm and you take it off the stove, it cools down faster than aluminum would, which is also beneficial. Okay? Using your specific heat calculations and using your numbers, the question is how many calories are needed to warm 15 grams of water from 12 degrees Celsius to 36 degrees Celsius? So we should probably give you kind of an equation to use. So your equation for specific heat is going to be Q equals mc delta T. Q being energy in either calories or joules. M is mass, typically in grams. C is your specific heat. And then delta T, delta means change in, T is temperature. This is your change in temperature, which can also be written as T final minus T initial. Okay, so that's going to be our equations. Here we go. How many calories are needed to warm 15 grams of water from 12 degrees Celsius to 36 degrees Celsius? So I have Q equals mc delta T. Q is what I'm looking for. M is going to be 15 grams of water. C, the specific heat of water, from that last page, we know is 1, I'm looking for calories, is 1 calorie per gram degrees Celsius. And it changes from 36 degrees Celsius, or from 12 degrees to 36 degrees. So 36 minus 12, final minus initial, is going to give me my change. If I multiply and calculate all of that, I'm going to get an answer of Q equals 360 calories. Okay, I'll have you try this next one. I have your answer here. So 67.8 kilojoules should be your answer. But a 225 gram sample of hot tea cools from 95 degrees Celsius to 23 degrees Celsius. What is the energy loss in joules, assuming tea has the same specific heat as water does? And in this case, the specific heat of water is 4.184 joules per gram degree Celsius. So try that. Make sure you can get to 67.8 kilojoules. And if you're struggling, then come see me and we will figure it out. Moving forward, we kind of talked a nutritional calorie, a capital C calorie, is the same as 1,000 little c calories, same as a kilocalorie. And we find the number of calories by using what's called a calorimeter. A calorimeter is where you burn something that heats up water outside of it, and we measure the temperature change of the water to find the calories in the food. So I have a setup here. Inside of this little pot is some food. Inside of this is a bunch of water. We burn the food, which heats up this container, which heats up the water, and we measure the temperature change of the water, is how we measure and find the number of calories. So for example, we have a 2.3 gram sample of butter, a fat that is placed in a calorimeter surrounded by 600 grams of water at an initial temperature of 17 degrees Celsius. After combustion of the butter, the water has a temperature of 52 degrees Celsius. What is the caloric value of the butter? Oops. Okay, and so here we go. We're looking for calories, so we're looking for Q. Q equals mc delta T. I know Q is equal to the mass of my water, because that's what I know, is 600 grams. Times the specific heat of water in calories. We're looking for caloric value, so we're looking for this, the nutritional calorie. That's the caloric value. But I know that my little c calories is 1 calorie per gram degree Celsius. I know my temperature change went from 52 to 17, or 17 to 52, sorry. 52 degrees. I'm going to make that a better 2. So I'm from 52 degrees. I got to 52 from 17 degrees Celsius. If I multiply all this across, I get a Q value of 21,000. That's little c calories. For caloric value, I need the big C, or the kilocalories. So I'm going to divide this by 1,000, and I get Q equals 21 kilocalories, or capital C calories. So this one should be 21,000 little c's, or 21 kilocalories. All right, I'll give you one to practice on your own. A 5.4 gram sample of glucose, a carb, is placed in a calorimeter. The water in the container has a mass of 1,000 grams and an initial temperature of 24 degrees Celsius. After the glucose is burned, the water temperature is 46 degrees Celsius. What is the caloric value for glucose? So you can use the same process you used on the last one. Try that. You should get to this answer. If you have troubles, I will talk to you. We'll discuss it. We'll figure it out. But this is where we're trying to go to. Okay? If we're talking food, food has calories associated with them. So for example, we have these things called carbohydrates, which produce roughly 4 kilocalories per gram. So for every gram of carbs, you get 4 kilocalories of energy. Fats produce 9.1 kilocalories per gram. Proteins are back to the 4 kilocalories per gram. We're going to practice with some nutrition label questions. Okay? So here's your review questions. So I want to know why cooking pans are made of aluminum, iron, or copper, as opposed to other substances. Substance A and B with the same mass and initial temperature absorb the same amount of heat energy. The final temperature of A is 55 degrees Celsius. Is 55 degrees Celsius higher than that of B? What does this tell you about the specific heats of A and B? And then you have one more set of questions, which are, I want to know how many, here's your energy calculations. So work through these 3 questions. If you have questions, come see me and we will get it figured out. But thank you for your time, and I look forward to working with you as we talk about gases and energy.